Equilibrium means that forces are balanced in any direction and there's therefore no movement going on. This diagram shows the forces acting on a particle to keep it in position, and we're being asked to work out what the force F is. So to do that, we're going to resolve horizontally. And before we can do that, we need to work out what the horizontal component of the F force is. So looking at it here, forming our triangle, then we can see that this force here is adjacent, and therefore that's going to be F cos 45 degrees, and F cos 45 degrees is going to be F over root 2. So we can resolve the other side as well. So we've got a 35 Newton force. We want its horizontal component, and again we can see that's a cos situation because it's adjacent, and so that's going to be 35 times cos 30, which means it's 35 times root 3 over 2. So put those together, we've got F over root 2 equals 35 root 3 over 2. Therefore F equals 35 root 6 over 2. And if we calculate that, we find that that's 42.9 newtons. Now we know what F is. We're asked now to find out what the mass of this particle is to the nearest gram. So to do this, we now need to resolve vertically instead. So we need the vertical components of the F and the 35 Newton force. They're going to balance the mg force, the force of the weight of the particle going in that way. So mg will equal F sine 45 degrees this time, plus 35 times sine 30 degrees. So that's going to be our 42.9. That will be over root 2 plus 35 over 2, because sine of 30 is a half. So if we work all of that out, we will find that that's 47.8 newtons. But we want just the mass, so obviously we now need to divide that through by g to get the actual mass of this object, and doing that leads us to 4.881 kilograms.